Hi Calculus 3 students. This is the part number 4 of the exercise on calculus with parametric curves, so the end of the section exercise. So we are given the same curve as before. Okay, so first of all, let's recap. Part 1, 2, 3, we found the x and the y intercept. They're right here. Okay. In part B, we found both the first and the second derivatives. And in part C, we use them to find where the curve has horizontal tangent line or vertical tangent lines. We also use the second derivative to determine what are the values of t for which the curve is concave up or concave down. And this is displayed over here, okay? Now what we want to do is to use all this information to sketch the curve with the correct orientation. So first of all, let's have a look at this point, right? We have a very high y coordinate here at 20 and a very high x coordinate at 15, okay? And if you remember correctly, 20 was corresponding to the value of t, which is -2. That's how we got the y-intercept. If you are not sure, go back to part number 1 and you will see that. So this will be important as we cover concavity. So the first thing we want to do is let's actually sketch the axes. Okay, so the y and the x-axis. Now you do have a little bit going on in the negative part of the graph, but a vast majority happens on the positive part. So let's just extend this a little bit. So this is gonna be x, and this is y. Okay, and we're not gonna put scales. What we're gonna do is we're gonna label our points. So for example, begin with the y-intercepts. So there's one here at 0, 0, and we're gonna put it around here. So this one is 0, 20. Okay, we're just gonna label them. 0, 0, it's no use to label it because it's very clear where it is. X-intercept, we have 0, 0 and 15, 0. So this is also the x-intercept, obviously. We don't need to write it twice, but we have one here at 15, 0. So approximately here, let's say. 15, 0. Okay? Then we know that we have horizontal tangent line at 0, 0, so the point is here, and 8, 4. So 8, 4 maybe is over here. Okay? 8, 4, okay? And we know that the tangent line is horizontal, so we're going to sketch something like this just as a guideline, right? We have to draw the curve in a way that it goes from 0, 0 up to here, and then goes down, or maybe goes up, we don't quite know. But we have to somehow like make the curve in this direction at 8, 4, okay? It's the same at 0, 0, so again, let's sketch that guideline here that we have to ensure that our tangent line is horizontal here. We have a vertical tangent line at the point -1, 4. So over here maybe. Let's actually, okay, so it's not up to scale and it shouldn't be, right? So let's put it over here and let's label it. We have -1, 4. Okay. And then again, just as a guideline, let's sketch like a vertical, like double arrow like this, showing that the curve should have a vertical tangent line right here. Okay, now here's the time to talk a little bit about concavity. So you should remember that this green point over here corresponds to t equals -1. This orange point corresponds to t is equal to -2. This point right here corresponds to t is equal to 0. And that's also helping us for the orientation, by the way. This point is very easy to see that this is t equals to 2. And this one, I believe, should be t equals 3. Let's see that. So we have like 3 squared, which is, yeah, exactly. This one is t equals 3. Okay. So first of all, that's helping us for the orientation because we know that the curve is going from here to here, to here, to here, to here, and then and so on. Then we just need to have the concavity, okay? So the first thing to note is this value, -1 minus root 3. So -1 minus root 3, what's important to know is that it's below -2, which means that like it's gonna be concave down like this. Okay, so it's gonna be concave down here. But eventually, like when t is equal to -1 minus root 3, it's going to become concave up. So it's going to go like this, okay? Now the orientation is like this, remember? Okay. After that, from -1 to 0, the graph is actually from -1 to here, like, okay, so -1 plus root 3. What's important to know is that it's between 0 and 2. And it's bigger than 1, but that is not that important. So it means that somewhere along the lines here, we should have a change of concavity. So this is like t is -1 plus root 3. Like the point should be over here somewhere. So what does it mean? It means that the curve will be concave upward from here to here, like this, okay? From here to here, like this. And then will become concave down here, and concave down, I believe, for the rest of the time. Yes, until infinity, exactly. So, so then the curve will become like this. Okay. So here you are. This is what the curve, the parametric curve C looks like. So I hope this was helpful. See you either in class or in the next video. In the next two videos, I'm going to show you how to set up for the area and how to set up for the arc length of some portion of this curve. We will see. See you there.